So, do you guys remember the distance equation? Here we go. Distance equation? Rate times time. Distance equals rate times time. What does that mean? What's rate mean?
Miles per hour.
Like speed. Yeah, and we measure speed in miles per hour. So let's say we were traveling along about 60 miles an hour. What is, for 3 hours? 3 hours would be the what? Time. So how far would we have traveled? Okay, what does miles per hour mean? Means
60 miles in 1 hour.
in 1 hour you will have gone 60 miles. That's the way we measure speed. How far would you have gone in an hour? So if there's 3 hours, then you would have gone 360s. You would have gone 180 miles. So this is what distance equals rate times time means. The speed times the hours equals how far you would have traveled. Okay. So distance equals rate times time, or rate times time equals distance. Basically, that's what we're using. So in number 11, let's jump in here. Andy won a race by sailing 20 miles an hour. What's 20 miles an hour is the what?
Distance.
No.
No, rate.
Rate. 20 miles an hour is the rate. Okay. For 6 1/4 hours. 6 1/4 hours is the what? 6 1/4 hours. Shh, no. Is the what? It's the time. So you do rate, 20 miles an hour, times time, to get the distance.
We're on 11?
Yep.
They said 11 through 20. Pay attention.
Focus.
You start at 11?
Yes. It's coming to her every day, Jordan.
Those glasses can see very well.
You can't. Those are not prescription, I'm guessing.
No.
The heart glasses don't help. Okay, what's that come out to? 125?
Yeah. Yep.
125 miles. All right. Number 3. Well, if I assign 10, there's probably a reason. Right? 13. An airplane travels 2,800 miles from New York to L.A. So 2,800 would be the what? No? Distance. Rates are always like miles per hour. If it just says miles, that's a distance. So 2,800 miles, I'm going to put that for the D, for the distance. Okay, then it says, in 7 hours. 7 hours is the what? The time. So what I'm missing is the rate. So time times rate. So how would I solve this little equation here? Divide by 7. So that would be 400. We're talking about rate, so it'd be like miles per hour. We're talking about airplane though, so it's not a car. Okay, 14 is where it gets, let's call it interesting. Or 15, I guess, in our case. So, yeah, all the rest of them, so 11, 12, and 13 are like really quick little equations. 14 on is not so quick. 15 says, Mr. Taylor rides his moped down the country road in front of his house. His wife and their 2 sons ride bicycles in the opposite direction on the same road. Okay, so what we need to do on all these problems first is kind of get a picture of what's going on. So Mr. Taylor is going one way on his moped. His family is going the other way on bikes. So what does the picture look like? It looks like, I'm not going to draw a moped and bike. That. They're going in opposite directions. They start at their house, head opposite directions. So each of these arrows represents a distance. There's Mr. Taylor's distance, so call it T, and the family's, everybody else's distance over here, call it F for family. Okay, I don't know their distances. I don't know this distance or this distance. So what we're gonna write in for those is a rate times a time. Rate times a time. You could say this is like rate 1 time 1 and rate 2 time 2. Mr. Taylor has his rate and time and the family has their rate and time. Okay. The arrows, that's kind of how you set it up, and then we're going to keep reading and plug in the info that they give us. It's probably Allison. Go. Hello? Okay.
Hi, Allison.
No, Allison. No.
Jared was going to be crying the whole time you're gone.
I am.
It'd be a mess.
Aw.
Shut up, Allison.
Okay, what was I talking about?
The rate times
Oh,
time.
okay, I was going to read some more and then we'll plug the numbers in.
Gotcha.
It says, let's see, if they leave at the same time and Mr. Taylor travels 24 miles an hour. So 24 miles an hour would be his what? Right. So where the R was, there's going to be a 24 now for his rate. It says the family were going on bikes and they were going 8 miles an hour. So 8's going to be the family's rate. Okay, now what it doesn't tell us is their times. However, it does say they started at the same time. So we know that their times are equal. So that's the variable because we don't know what it is. So I'm going to call them both T because they're going to be the same amount of time.
Can we multiply that?
No. The other fact that I didn't read is the very last part. How much time will pass before they're 24 miles apart? So where does the 24 miles go? It goes all the way from here to here. So like they're going to be that far apart. So that goes right there. Okay. This picture has 3 different distances. Mr. Taylor's distance, this arrow, this stuff. The family distance, this stuff. And then the total distance, 24 miles. What is the relationship between these 3?
What do you mean?
We need an equation to set up. So how are these 3 related to each other? No, not like that. No. Okay, it's this distance, Mr. Taylor's distance, plus this distance, the family distance, gives us the total distance, which is 24 miles. So, in other words, 24t plus 8t equals the 24 miles. Okay, that's the hard part, and then the easier part is solving it. So, because this goes back to like chapter 2. What would we do to solve this? Notice I'm putting little tails on my T because of these problems right here. That's what I started doing that. Because they look like pluses otherwise. Yeah, 24t plus 8t is 32t. So, yeah, just basic algebra after you set it up. That's the hard part. 24 divided by 32.
0.75.
Okay, now what does T stand for though?
Time.
Time. Would you say 0.75 hours?
No, 9.
Really? Whoever said that. What would we probably actually say instead of 0.75 hours?
3/4 of an hour.
Might say 3/4 of an hour. You'd probably just say 45 minutes.
Oh, no.
Did you not know 3/4 of an hour is 45 minutes?
No.
That's depressing. That's actually.
You probably did it easy.
Who didn't know?
Me.
1/4 is 15 minutes, yeah. Goes around the clock. Maybe
Wait,
it gets
so
because
15 plus 15
Huh?
plus 15 plus 15 is 60?
yeah.
Yes,
Oh, 10 minutes.
cause 15 squared is 30.
It's probably because we have digital instead of those clocks
Oh.
that we don't know that stuff anymore. Anyways, not a big deal. If you put 3/4, I wouldn't count it wrong. Okay.
I put 0.75.
How dare you?
0.75 minutes.
That would actually be wrong.
Hours.
0.75 hours, yeah. Okay. 17.
This one's my favorite.
So they kind of change a little bit. They all kind of follow that pattern, but little things keep changing. So hopefully we get all the tricks. Steve leaves the corner. So remember on the first one, what I started with was the arrow diagram. So we got to think, what does this picture look like? And that'll help us set up the equation later. So what should the arrows look like? Steve leaves the corner of First and Maple on his bike and travels an average speed of 9 miles an hour. 2 hours later, his brother leaves from First and Maple, following him on a moped traveling 27 miles an hour. How long will it take for him to catch up with Steve? Okay, what do the arrows look like?
They're going the same way.
Same direction. Not only are they going in the same direction, the brother's going to catch up to Steve, so they're the exact same length. So it's most of these problems either look like 15, where the arrows are like working together to make the distance, or the arrows are identical, like 17. So each of these arrows is a distance that's going to get its own rate and time. I'll call the top one Steve and the bottom one brother. Okay, I'll read again and we'll plug the numbers in wherever they go. What were the numbers?
9.
Steve is going 9 miles an hour. So where does the 9 miles an hour go?
Steve.
Steve's rate. 9 miles an hour would be a speed, his rate. And then his brother was going 27 miles an hour because he was on a moped. So I'll put a 27 in there. Okay, do we know their times? No. But we do know that Steve left 2 hours earlier. Okay, if Steve left earlier and then his brother caught up, would Steve have been traveling shorter or longer than his brother? Yeah, he left earlier, but he was going slow on his bike. His brother caught him pretty fast. So Steve's time would actually be 2 less than his brother. So for his time, I'm going to put t minus 2. If I call his brother's time t, then Steve's time would be 2 less than that. So it's t minus 2.
Wait, why?
Because Steve left 2 hours before his brother. It's kind of like if we both headed towards Dallas, but I started like 2 hours early, and you caught me at Dallas, who would have been traveling longer? Me. So, oops, did I do it backwards? Oh, I did do it backwards, my bad, sorry. Steve's time would have been 2 hours longer, so he should have got the +2, my bad.
I'm so confused.
Yeah.
Okay. Steve left earlier, therefore he must have been traveling longer. Does that make sense?
No.
Okay. If you head out towards Dallas,
Well, I get that part, like that he's been traveling further, but I just don't.
okay, well, if his time is 2 hours longer, and I call the brother's time t, I could call his time t plus 2. Because it's whatever this time is, his is going to be 2 more than that. You could also do it the other way. If you call Steve's time t, we could have called the brother's time t minus 2.
Why
Because
didn't you do like times 2?
times,
I don't know.
okay, it's just 2 hours more. It's not twice as much. It's 2 hours more. Okay, that's all the info they gave us. What's the relation? There's only 2 distances on this problem. Steve's distance, brother's distance. What's the relationship between those two distances? They're equal distances because the brother is catching up to Steve, so their distance will be the same. So they're equal. So 9t plus 2 equals 27t. Okay, that's the hard part, setting it up, and then the easy part, you guys will probably get this right, is solving it. So, distribute. What do we do when t's are on both sides? Subtract 9t, get all your t's to one side. And what? Divide. So, anyways, 18 divided by 18, so t is 1. What does that tell us? T, yeah, that's right. T stood for the brother's time, so he must have been traveling for 1 hour. Steve's time would be t plus 2, so Steve's time is 3 hours. I don't know how to write that. Call it T1, T2.
What do we need to write for the answer?
Yeah, you have to read the question to make sure you're putting the right answer. Could
We
be.
need to write
How long will it take the brother to catch Steve?
so 1 hour.
1 hour is correct. Okay, one more. 19.
12 knots.
Yeah, let me read that sentence first. A fishing boat leaves Tampa Bay at 4 a.m. and travels at 12 knots. They measure boat speed in nautical miles, and they call the rate knots. It's just a boat thing. A nautical mile is like 1.1 miles. So it's like miles per hour, basically. So the 12 knots is the speed. My theory is they used to measure ocean distances with knots on a rope and like, count them or something. Anyways, 12 knots is his speed. So fishing boat leaves Tampa Bay at 4 a.m., goes 12 knots, travels at 12 knots. At 5 a.m., so an hour later, a second boat leaves the same dock for the same destination and goes 14 knots. How long will it take the second boat to catch up with the first one? So what would our arrow diagram look like? Yeah, it's a twin of 17. Boat B is catching up to boat A, so they will have the same distance, just like 17. So they both get, this will be the first boat, this will be the second boat. I don't think they named them. So they both get their own rate and time. So for, let's see, the first boat was going 12 knots. 12 is the rate. The second boat was going 14 knots. So 14 will be that R. Okay, what about their times? The first boat left at 4 a.m. The second boat left at 5 a.m. Who was traveling longer? The first boat. Because he started at 4. How much longer travel time would he have? 1 hour. So we could call his time T plus 1. If we call the later boat just T. Okay, what's the relationship between these two distances? Why do the arrows look identical? They're the same distance. So this distance equals that distance. So it's just the two things are equal. It really is a repeated number, 17. There are a few different ways these set up, but okay, and then the algebra steps. You got whoops.
So it takes 6 hours? No.
Yeah.
6.
So T is 6, which T is what we call the second boat time. We just call it T.
What are the hours?
So it took 6 hours for him to get there. That means the first boat must have been traveling for T plus 1, 7 hours. Well, did they ask? How long will it take the second boat to catch up to the first one?
No.
No, 6 hours. Basically, the second boat was traveling for 6 hours. That's kind of the question. Okay, now here's what's going to happen. I want you guys, well, I guess you have to do number 12 still. 12, you can do that one pretty quick. It's just D equals RT, plug the numbers in. Distance equals rate times time. 14 is the first one, that's kind of the harder one. So in about 5 minutes, we'll check and see if you got that one set up right. I'm not going to go through the whole problem, but we'll see if you got it set up right. We'll do that in like 5 minutes.
Somehow I get the harder ones more than 12. I don't know.
So on 12, you're just using the equation D equals RT. Distance equals rate times time. And you're plugging the two numbers in wherever they go. And then solving
How
for...
do you know, like, the difference between rate and time?
Rate is like speed, so that's like miles per hour.
What
Time is
MI
like 3 hours or whatever. Huh?
What's MI stand for?
Miles. That would be a distance.
But it says MI dash hour.
That would be miles per hour. That would be
So would that be the time?
no, miles per hour is your speed, your rate.
Oh.
So yeah, speeds are always like miles per hour or kilometers per hour or something like that. Time is in hours. Distance is like miles or kilometers or something like that.
I didn't do it the same. What did you get? Oh, wrong number.
It should come out like a nice number.
So, is it 1,000 or 1,000?
No.
Or
Yeah, because the question is how long will it take the train? So that would be like how many hours would it take the train to make the trip? So 372 is the distance. So that means it should be like over here by itself. And 62 is the speed. So it should set up like that. 62 miles an hour is the rate. Yeah.
oh.
Start with the arrows, plug in a rate and time, Well, you're just trying to picture in your head, like, where are these people going and what does it look like? Just try it on your own first. No, I'm just gonna wait. Help everybody at once.
That redhead thing. That thing on your head is messing up your brain. That's why you can't think. Really? I'm done.
Cutting off circulation.
He's smart. He's smart.
I mean, he's a junior in a ninth grade class.
Sophomore.
Uh,
Yeah. What's sophomore?
Oh, you're sophomore? I thought you were junior. Man.
No.
no, Luke's a junior.
Any luck?
I think I did it, but I don't know if I got it. I have the arrows.
Okay. Each arrow gets an R and a T, and then you plug in the stuff they tell you.
Wait. What?
Like, not time to give up the fight yet. What I do on the word problems is I give you 1 point if you convince me you tried,
Why you?
and you get another point for the right answer. Okay,
Oh, wrong one. Wait, wrong one.
our 5 minutes are about up. You guys set it up?
Yes.
Okay, Sadie leaves Lewiston for Clarksville, and Monica leaves Clarksville for Lewiston. So what do the arrows look like? Come together. That's what they look like. I'll call that one Sadie and this one Monica. Can't draw a straight line. That's the arrows. Okay, each arrow gets a rate and a time. Okay, it says Lewiston and Clarksville are 388 miles away. So where does 388 miles go? Yeah, middle, overall, kind of like we did on 13. It goes all the way across. So it's 388 miles all the way. And it's not the rate and it's not the time. What else does it say? Sadie's going 52 miles an hour and Monica's going 45. So Sadie gets a 52 for her R. Monica gets a 45. Okay, what do we know about their times?
It's just in the same thing.
Same time. So they're both going to get the same variable, T. So this is like number 15 actually. Okay, now here comes the magic. How are these three distances? Okay, we have distance 1, distance 2,
And then distance 3.
and distance 3. What color did I not use? Orange. I don't like orange. The pink on the board doesn't work very well.
Neither does orange.
Neither does orange. There's not a good orange on it.
Yellow.
Use the black background.
Use yellow.
It still doesn't look very good. The orange doesn't. Anyways, how are these three distances related to each other?
They're both the equivalent of 388.
Right. These two together make this the big one. So that plus that equals that. So 52t plus 45t
97.
equals 388. Okay, this is when I get off the bus because this is even. You guys can do that. I'm sure it's how long did they travel before they met? That's the question. So just solve for t.